similar to what you have seen with zinc. But in case of aluminium, there is a slight difference. If you take metal aluminium and treat it with sodium hydroxide, in that case, you have to do this reaction in presence of water. So that means there is one more reactant, and that is water. So aluminium along with sodium hydroxide along with water will now give you sodium aluminate. You know what is sodium aluminate's formula? It is NaAlO2 along with hydrogen gas. Now, as you know, we will always take the hydroxide of the metal. So let us take aluminium hydroxide, treat it with the same alkali NaOH. But this time don't add water to it. Do it the reaction in excess of sodium hydroxide. You will get sodium aluminate NaAlO2 but along with water. Similar manner, you can take amphoteric oxide of the same metal, that is aluminium oxide Al2O3. Treat it with the same alkali NaOH will give you sodium aluminate NaAlO2 along with what? Water. Now you can take the same metal along with its hydroxide, along with its oxide, and treat it in the similar manner with hot concentrated KOH, that is also known as caustic potash, potassium hydroxide. You will get the same products. Only difference will be, instead of sodium, you will be getting potassium. What is amphoteric oxide? An oxide of a metal which can react with both acid as well as base to give salt and water. Let us consider one more salt, and that is lead nitrate, PbNO3 twice. Treated with the same liquor ammonia, NH4OH will give you ammonium nitrate, NH4NO3 along with lead hydroxide, PbOH twice, a precipitate again indicated by an arrow downward. It gives you a precipitate which will be insoluble in excess of ammonium hydroxide. So now you know the difference. If you take lead nitrate and treat it with sodium hydroxide, you get a precipitate of lead hydroxide which was soluble in excess of sodium hydroxide. But the same precipitate is insoluble in excess of ammonium hydroxide. Some application-oriented questions, like they can ask you, give a chemical test to differentiate between ferrous sulfate and copper sulfate. Then what can you do? Very simple. Take these two salts and put sodium hydroxide, or you can use even liquor ammonia also. Put this inside the respective salts. And what you will notice? You will get a precipitate. But as you know, the colors of the precipitate will differ. Say for example, if you take copper sulfate and put sodium hydroxide or ammonium hydroxide in it, you will get ferrous hydroxide, which is dirty green in color. Whereas if you take copper sulfate and put sodium hydroxide in it, you will get copper hydroxide, which is pale blue in color. So you can easily differentiate between ferrous sulfate salt and copper sulfate. Similar manner, they can ask you, how will you differentiate between zinc sulfate and lead nitrate? Again, you can use ammonium hydroxide. When you put ammonium hydroxide in zinc sulfate, you get a white gelatinous precipitate which will be soluble in excess of ammonium hydroxide. Whereas if you take lead nitrate and treat it with ammonium hydroxide, you will get a precipitate of lead hydroxide which is insoluble, and the color of it will be chalky white. Similar manner, you can select any salt and differentiate using alkali NaOH or ammonium hydroxide. They can also ask you, give a test to differentiate between sodium hydroxide and ammonium hydroxide. Then you can select any salt. Let's say for example, you select copper sulfate and put it in sodium hydroxide. You will get a pale blue color precipitate which will be insoluble in sodium hydroxide. Whereas if you take ammonium hydroxide and treat it with the same salt, copper sulfate, you will get pale blue color, but that pale blue color copper hydroxide will be soluble in excess of ammonium hydroxide. You know it. You will get inky blue, that is tetraamine copper sulfate. The weightage of this topic is approximately 2 to 3 marks. A question on this topic can be framed in both section 1 as well as section 2. The question on this topic will be based on identifying the color of the precipitate, the nature of the precipitate, whether it will be soluble or insoluble in excess of caustic soda, or it can be liquor ammonia, that is ammonium hydroxide. Now let us consider certain board questions. This question which we are going to start with was asked in 2004. Let us see what is the question asked. Sodium hydroxide solution is added first in a very small amount and then it is added in excess to certain salts such as copper sulfate, lead nitrate, zinc nitrate, calcium chloride and iron sulfate. So let's start with the first one. With respect to copper sulfate, the question asked was, what is the precipitate color when NaOH is added in a small amount? And also the nature of the precipitate, that is whether it is soluble or insoluble if excess of NaOH is added. To start with the solution, let us consider the first salt, that is copper sulfate, CuSO4. When we add a small amount of NaOH, you know it,